Hello class, in today's lecture we're going to cover solving radical equations. So I'm going to go over a few examples to show you how we can do that. Let's remember we have an expression like this. The inside of the radical, it's called the radicand. So AB is my radicand. This is your radical sign. So this is your sign, your symbol, okay? The small number that goes in here is called the index. If you have something that is just this, we know this is the square root. When we don't see anything, the index is a 2, okay? Anything other than a 2 will be noted as here is a 4, okay? So, there are a few steps that we need to follow in order to solve a radical equation. We want to always start by isolating the radical sign. That's going to be our first step. We're going to do everything that we have learned so far of solving an equation to isolate the radical sign. The second step is going to raise both sides of the equation by the index of that equation. I will show you in the examples. And the last step will be to check your answer to see if you have a valid or invalid answer. If both sides of the equations are not equal, then we need to know that. Okay, so I'm going to start with my examples here. We're going to start with the basics. So if I have an example, my number 1, and it's m equals 3. The question is to solve for m. I want to solve, right? And this is the equation I'm given. Notice there's a radical, and this is why they're called radical equations. So the first thing I'm going to do is to isolate my radical. Well, my radical is already isolated. It's by itself. There's nothing being added or multiplied or divided by it. So it's by itself. So I already did step 1. The second part is going to be to raise both sides of the equation by its index. That means the idea of that comes for you to eliminate the radical. You want to go ahead and eliminate the radical. And in order to eliminate that, the opposite of a radical is to square. In this case, it's a square root to square both sides. Sometimes it could be cube or like this one to the 4th. So I'm going to go ahead and square both sides. And as in any equation, you have to make sure you do the same to both sides. So I square both of them. This and this will cancel, leaving me with m equals 3 squared is 9. Okay? Now I need to check my answer. So to check, I'm going to substitute the value I have found for m into the original equation. It's going to be 9 equals 3. Square root of 9 is 3. Does 3 equals 3? Yes. So this is a valid answer. Okay? Let's do another example. We have cube root of 2a equals 2. So this is my other example. Again, I am solving for the letter a. Is my radical isolated? Yes, it's already isolated. So what's the next thing I need to do? I need to get rid of the radical. And to do that, I need to raise both sides of my equation by the index of my radical. In this case, it's 3. Okay? This and this cancels. I am left with 2a equals 2 cubed. 2 times 2 times 2 gives you 8. Then I'm going to divide by 2 because my goal is to solve for a. The opposite of this multiplication is division. That gives me 4. So my answer for a is 4. Now I need to check if it's a valid or invalid answer. So I'm going to go ahead and substitute the value of 4 for a. Cube root of 2 times 4 equals 2. 2 times 4 is 8. Cube root of a is 2. 2 equals 2? Yes, so that's a valid answer. Okay? Let's go ahead and see another example. Perfect. Okay, so again, I am solving for the variable. Now, is my radical isolated? I don't think so, because it has this 3 here being added. So I need to get rid of the 3 first. So I'm going to go ahead and subtract that to both sides. Three. Now my radical is by itself, so I need to go ahead and square both sides. So I'm going to raise it by the index. In this case, is 2. So I have y equals 9. Okay. Now I need to go ahead and check my work to see if that 9 is okay. Make sure we write to check. We want to be organized with our work. Taking notes in a math class, you want to add a few words to it. That way it makes sense, like to check, when you're taking your notes. So, I have 9 plus 3 equals 6. Square root of 9 is 3. 3 times 3, 6. 3 plus 3 is 6, which does equals to 6. Therefore, that's a valid answer. Some of the times you don't have to actually write down the check. Like if you could just do it on your head, say square root of 9 plus is 3 plus 3 is 6. You already know that. But I want to make sure I show you all the steps. That way we understand it. If you have any questions, you can always ask me. Okay, so those are 3 examples. We have a few more to go. I'm going to go ahead and erase this. That way we can do the rest. Okay, so we got our other example. So that was 3, now we're at 4. And notice it's the same thing over and over again. Some of them just look a little bit more steps. And by the end of it, the last one is huge. So for this example, I'm doing the same. I need to solve. Okay, so I need to solve for my variable a. Now, is my radical isolated? I don't think so. It has this plus 6 over here. I need the radical term to be by itself. So I'm going to go ahead and subtract 6 to both sides. Then I have radical a minus 3 equals 4. Now my radical is by itself, so I need to go ahead and raise both sides of the equation by its index. In this case, it's squared. So I'm going to square both sides. So this and this will cancel, so I have a minus 3 equals 16, right? 4 times 4, 16. I'm going to go ahead and add 3. So a equals 17, 18, 19. Excellent, so a equals 19, but now I need to check, right? Make sure I check my work. So to check, I'm going to substitute the 19 for the a in my original equation. So I have 19 minus 3 plus 6 equals 10. 19 minus 3, I believe that's 16. Square root of 16 is 4. 4 plus 6, it is 10. So 10 does equals 10, so this is a valid answer. Okay. So let me go see another example. We have a few for this lesson. So 5. Okay. So, first step, to isolate my radical. I have radicals on both sides of the equation. So in this case, we cannot really isolate the radical. They're already by themselves on each side of the equation, but we can't really isolate them both on one side. Okay, because if we add that here, it will be subtraction and you want them to be by itself. So in order for us to solve for x, we're gonna square root both sides. So I'm gonna go ahead and square root both sides. Okay. That and that will cancel. I am left with 2x plus 9 equals x plus 7. And now I'm simply got to solve for x. So I'm going to put all my x's on the same side of the equal sign and on my numbers on the other side. So I have, oops, making a mistake there. 2x minus x gives you 1x. Plus 9 equals 7. I'm going to minus the 9. So x equals -2. Okay, I need to go ahead and check my answer to make sure if this is a valid answer. And if it's not valid, simply note that it's an invalid answer. So I'm going to have 2 times -2 plus 9 equals -2 plus 7. 2 times -2 gives you -4 plus 9 gives you 5. Square root of 5. -2 plus 7 gives you square root of 5. So, square root of 5 does equal to square root of 5? Yes. So that's the valid answer. Excellent. Okay, I believe the next example is a little bit long. So I'm going to go ahead and erase now. Yeah. I'm going to go ahead and erase. The next example. So I have example 6. I'm doing the same. We need to solve. Okay. So the example is square root of x plus 4 plus 2 equals x. I need to solve for x. Okay. So I'm going to start the same way. I need to isolate my radical sign. So the first thing I'm going to do is to subtract 2 to both sides. Square root of x plus 4 equals x minus 2. Now I need to go ahead and square both sides, so in order for me to cancel the radical sign, I'm going to go ahead and say square both of them. This and this cancels, right? So I am left with x plus 4 equals, now note this, it's x minus 2 squared. That means you're going to multiply x minus 2 times x minus 2. So x minus 2 times x minus 2. Okay. Here we're going to go ahead and FOIL, or you could call this a double distribute, whichever you like best. It's the same. So let's use different colors. Okay. I'm going to ignore this side for the moment and I'm going to work on this side. X times x gives me x squared. X times -2, -2x. -2 times x, -2x. -2 times -2 is a positive 4. Okay. So now I need to simplify on this side. -2 minus 2 is -4x plus 4. Now the goal is to make it equal to 0, so I can see which of the methods that we have learned so far I can use to solve this equation. I'm going to minus 4. This cancels. Then I'm going to minus the x. Okay. I want you to take a look at this. X squared minus 5x. Think of what we have learned so far. What method? A method that we have talked about a lot, and it's extremely important, and it's not going to go away. Do you think we can use here in order to solve this equation? Pick up my marker and dropped. Okay. Hopefully something came up, and that was factor. And we're going to find the GCF in order to solve this equation. My GCF is x. So I have 0 equals x, x minus 5. I'm going to take this over here. And I'm just going to rewrite it since I don't have more space. 0 equals x, x minus 5. Now I need to solve for each term. So this is one term and this is one term. So I'm going to say x equals 0, x minus 5 equals 0. This is already solved. Here I need to add it. Okay? So these are my two answers. Wow, so much work, right? So what do you think we're going to need to do now to see if both of them work? We need to check my solutions for invalid or invalid. So now we're going to check. Okay. So I'm going to substitute one value at a time. So I'm going to start with the 0. So I have 0 plus 4 equals, or not equals, 0 plus 4 plus 2 equals 0. 0 plus 4 is 4. Square root of 4 is 2. We add that. Is 4 equals 0? No. So this is invalid. Now we're going to check the second one. So I have 5 plus 4 plus 2 equals 5. 5 plus 4 is 9. Square root of 9 is 3. 5, is that equal 5? Yes. So this is valid. We got one good answer. Excellent. Okay. So we isolate the radical. We then square both sides. We FOIL, double distribute if you like. Combine like terms. Let me do that here. Combine like terms. Then from here to here, make equal to 0. Oops, 0. We realize here, in order to solve for x, we have to factor, finding the GCF. Then we equal to 0 both terms and solve. And lastly, we check if our answers are valid or invalid. Let me see if I have another example for you. Yeah, we have one more. And this is a truly long one. So I'm going to go ahead and erase it because certainly I do not have space. I'm going to try to be organized with my work since this is a long one, very long. So again, we're going to solve for the variable. This is example 7. And it says square root of x minus 2 equals 1 plus square root of x minus 7. Okay. So the first thing, as always, you want to isolate your radical. But in this case, you have radicals on both sides of the equal sign. Okay? So there's nothing we can do there. So we're going to go ahead and square both sides. In here, the radical cancels, but in here it does not, because there's just there's two terms. It will only cancel when there's one term, like here. In this case, it does not. So my radical cancel here. I have x minus 2 equals, what do you think that is? I have 1 plus something square. That's a binomial, right? Two terms, 1, 2. And it's square. So I'm going to have to FOIL that. So I'm going to write it the same thing twice. So I have 1 plus square root of x minus 7 times 1 plus square root of x minus 7. Okay, I need to FOIL that. okay, or a double distribute. So it's going to be 1 times 1, 1 times a radical. Radical times 1, radical times radical. So I have x minus 2 equals 1 times 1 is 1. 1 times the square root of x minus 7 is plus square root of x minus 7. Square root of x minus 7 times 1 is plus square root of x minus 7. Radical times radical is going to be plus square root of x minus 7 square, right? Now what do you think is going to happen with this radical and this square? They're going to cancel. But let's do baby steps, one step at a time. Now we're going to simplify by combining like terms. So we're going to combine like terms here. Let me work the combine. Okay. So I have x minus 2 equals. This 1, can I combine it with something? Or no, at this moment. This 2 I can combine, right? They're the exact same, and there's a invisible 1. Should we know that right here? Okay. So I'm going to say 1 plus 2 radical x minus 7. Here, they're both going to cancel, so I'm just going to have plus x minus 7. Okay? Now, again, still combining like terms. Let's say 1 minus minus 7 will be negative 6. So I have 2 square root of x minus 7 plus x minus 6. I still have a radical sign. So what am I going to do with that? I don't want to have any radicals. I need to get rid of the radicals. So this is an example where you're going to have to do the same process twice, in the sense of you're going to have to square it twice. So now we just did all this work, and now we have to go back here and say, okay, now I need to isolate my radical. So then I can square both sides. So then I can check final answers. So here we're going to isolate the radical. So we're going to start by saying minus x. Cancels 2. Negative 2 equals 2 square root of x minus 7 minus 6. Then I'm going to add 6. I have 4 equals 2 square root of x minus 7. My radical is still not by itself. I have this 2 here. So now I'm going to go ahead and divide. Now, how do we know that we're dividing? When you have a number next to a radical like this, it's always multiplication. And the opposite of multiplication is division. So then it's 2 equals radical x minus 7. I feel like out of breath too. So, what do you think we're going to do now? Now my radical is by itself. So I'm going to go ahead and square both sides. Once I square both sides, go over here. I'm going to have 4 equals x minus 7. Now I just need to solve for x. So I'm going to go ahead and add 7 to both sides. And I have 11 equals x. Now we need to check our answer. A bit long. So to check. Okay, so now I need to check my answer. Thank God we only have one answer to check. So I have square root of 11 minus 2 equals 1 plus square root of 11 minus 7. 11 minus 2 is 9. Square root of 9 is 3. 1 plus 11 minus 7 is 4. Square root of 4 is 2. 3. Those equals 3. This is a valid answer. Yay! Yay! Okay, so I have given you about 7 examples, exactly 7 examples of how to solve a radical equation. So we have completed this section. Yes. Okay. Any questions? Just always, feel free to email me and let me know on the WhatsApp.